The first question, number 1, requires you to learn off by heart the size of the nucleus and the atom. This is something we did right at the beginning of the year. Unfortunately, you are going to have to learn these off by heart, so it's best to do it just before the test and when you're revising for the actual IB or the final or the mock or whatever. But the diameter of an atom is 10 to the minus 10, and the diameter of a nucleus is a little bit smaller, 10 to the minus 15. Okay, these are in your book in page 5. So if you have to divide 10 by the minus 15 by 10 to minus 10, what we're doing is we're subtracting indices, okay? We're subtracting indices because you're dividing. So what you end up with is minus 15 minus 10. You have a double minus, so this becomes a plus. So you end up with minus 15 plus 10 gives you minus 5, which is C. Question number 2 requires you to add vectors. Which of the vectors best represents the vector C, which would satisfy x plus y? So you have to add x and y using the nose to tail procedure. And you should do this to scale. I'm going to do it rough, okay, but you would do this properly. So you have x, which is approximately in this direction and in that size. And you would then add y, which goes up, and it's more or less the same size. So you can see that the resultant force is approximately, let's see, the distance from here to here. Okay, so you just need to identify from the vectors available which one is the most approximate, and you can see that it's definitely B. I've done it very, very rough. If these answers happen to be very similar, or the question's asking you to be a lot more precise, I would measure these and do it to scale properly. But that wasn't necessary in this question. Question number 3. The speed of sound V in a gas is related to the pressure P of the gas by the following expression. V equals square root of Kp. Which variables should be plotted in order to produce a straight line graph with the slope equal to K? This is a linearization exercise. You have to try and figure out how that formula there follows the y equals mx plus c format. As you can see, there is no plus c, so we can forget about that. And we can write the formula underneath it to see if it makes a little bit more sense. V equals square root of Kp. Now, square root means to the power of a half. So K to the power of a half and P to the power of the half. And you want a straight line. Now, the only way that you can get a straight line is if you plot on the y-axis V and on the x-axis P to the half. So now the problem with that is your gradient is going to be K to the half. And look at the question. The question specifically states which variable should be plotted in order to produce a straight line graph with a slope equal to K. This will not give us a slope equal to K. It will give us K to the half. So what options do we have? Well, we can try and figure out how to make K to the power of 1. And the only way you can do that is if you get rid of this half. And the only way you can do that is by squaring the entire statement. So if we square V, we end up with V squared. If we square k to the half, we end up with k. And if we square p, we end up with p. Now what are we going to plot on our graph? We now have v squared on the y-axis and p on the x-axis. And that gives us k as our gradient. So which option is that? It's B. Question number 4. This is a simple vector subtraction. So we have x and we have y. Which diagram best represents x minus y? So let's have a look at y. Y is normally in this direction, and so this diagram would represent plus y. What would minus y look like? Minus y would be exactly the same magnitude, but opposite in direction. So it would look like this. So x, which I'm going to draw it down here, is still like this, and minus y now looks like this. So really what you're doing is you are adding x plus minus y. So what would that look like? Well, if we join more or less the beginning of our triangle to the end there, that's our addition. And so the answer would be B. Again, if the answers to the multiple choice were really similar, if it was a much trickier question, it would be worth measuring and drawing this to scale, but it's not really necessary. Okay, so the answer is B. Question number 5. The length of rod is measured using part of a meter rule graduated in millimeters. Which one of the following gives a measure of the uncertainty? Well, what we have here is an interesting situation. We have a subtraction. To find the length of the object, you will need to find this position, and you need to subtract the second position from it. What is the rule for subtracting uncertainties? You add the absolute. So our first measurement would be, if we have a look at x1, something along the lines of 8 point, and it's in the middle, so it's 0.1 plus or minus, well, it's half the smallest interval, so it's 0.05. What is x2? This one here. x2 is pretty much in the same situation. It's 3.05 plus or minus 0.05. And let me go back and change my first one. I made a little mistake. Actually, it's 8.05. I don't know why I wrote 0.1, because it's in the middle, so it's 8.05. Okay, so we need to subtract the values. What happens when we subtract 3.05 from 8.05? We end up with 5. And what is our answer? 0.05 and 0.05. If we add those two absolutes, we end up with 0.1. Okay, so our answer is 5, but is it C or is it A? Well, it can't be A because 5 doesn't have the same number of significant figures as the uncertainty. So the correct answer is here because you have 2 significant figures in both readings. I hope that made sense. Okay, in this question, all you have to do is learn off by heart the fundamental units. Once you know those, it's quite easy because the derived units are all the others. So what are our fundamental units? The ampere, the second, the kilogram, the meter, and the kilogram there again. Okay, so which one of these gives you a fundamental unit and a derived unit? It's B. So the answer is B. Okay, this question is about lines of best fit. And the definition of a best fit line is a line that goes through as many of the plotted points as possible, trying to get close to the main coordinate point, but staying within the error bars. Okay, so if we have a look, well, it can't be these because it's most of the points are being avoided. You do often have a curve as a line of best fit, but not in this case. So it's either A or C, and as you can see, A is better because it goes through more points and only excludes one, whereas this one is a little bit less accurate. Okay, so the answer is A. Question number 8 is to do with percentage uncertainties. When you, remember, just do a quick revision, when you add or subtract quantities, you add the absolute uncertainties. But if you're multiplying or dividing, you add the percentage uncertainties. Now, what is the relationship we're looking at? Her calculated value of the kinetic energy of the glider will have an uncertainty of, well, kinetic energy is a half mv squared. So if we have a look, we have a mass and v squared. So what is the mass? 3%. What is v squared? 10 times 2. So we have 23. Okay, so this question, although it seems really wordy, okay, is actually a really simple linearization question. You have this formula, and A and B are constants. In an experiment to measure the deviation of nitrogen gas from ideal behavior, blah, 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 read all that. What is the actual question asking you? It wants you to draw a line of best fit, okay? So if we have a look at this graph, you will be able to do this much better than me, but you should be able to do a line a little bit closer that way, actually. I gave you credit if you just included from here to here, but please remember in future to do the complete line, okay, to actually include this intercept here. It's very important, and you'll see why in a moment. So this part, finding a line of best fit, that was really simple. Let's try the next bit. Now here it's asking you, use the graph to determine the values of the constants A and B in the equation. It's an equation, a straight line equation. So let's have a look. You have y equals mx plus c. Does that fit the format of this equation? Actually, it's a little bit fiddly still because A is a constant and B is a constant. So we need to rearrange our equation of the straight line a little bit. Let me draw it a different way. Y equals c plus mx. Now you can see that we're using, this is basically a linearization question, and it's saying if you have PV on the y-axis, which you do, and P on the x-axis, which you do, what does A and B mean? Well, A is the intercept. Okay, so you just have to find the intercept on the line. And B is the gradient. So you have to work out the gradient line. Okay, I'm going to give you the answers that you should get, but because I can't go back to the slide, I'm just going to sketch it out here. Okay, you have your line there. How do you find constant A? You literally just read it off the axis. Okay, so you find that value there. But don't just read it, which gives you a 12 point something, I think. You have to bear in mind that the axes have times 10 to the 2. So your answer should give you rounding up to two significant figures, 1.3 times 10 to the 3 plus the associated units. And then your gradient, you have to actually show your calculation. You have to do your y2 minus y1, which some of you did, okay? And it's rise over run. So in this case, it's rise over run. So you would get your x2, x1. Anyway, as long as in some way or shape or form, you show what this distance is using the axes, and you show what this distance is using the axes. Okay, then you work it out. You divide the change in y by the change in x. X. Okay, so your gradient will be change in y divided by change in x. And don't forget that the axes at the bottom say times 10 to the minus 5. And your answer should be approximately 1 times 10 to the minus 5, more or less. Now don't forget that this is a minus gradient, so you should also show the minus for that extra 5. And don't forget the units. These are on the axes.